In this video, I'm going to talk about the keyword abstract and how you can use it to inheritance hierarchies. So I have a MyDevice superclass and two subclasses here, and I have a device driver, which is pretty simple. I'm going to create one of each of them, a MyDevice, a MyPod, and my phone, add them to an array list of type MyDevice, and then print them out using a for each loop. So if I close this and run it, everything works. There's a MyDevice, a MyPod, and a my phone. However, if I go back into the MyDevice here and look a little bit more closely here, I can see that I'm creating three objects. MyPod, my phone, I understand, but a MyDevice, that seems pretty generic. I'm not sure if I know what a MyDevice is. And this is very common. When you create superclasses, you can start to have classes that are simply there as placeholders for information that are very generic in name and meaning. And MyDevice is pretty generic. I'm not sure exactly what that is. So when you do this, when you create inheritance hierarchies, you can actually tag a class as being abstract. An abstract class is a class that you cannot instantiate. You cannot create one of. It's simply here to hold instance variables, constructors, and maybe a toString method, or maybe you have a couple other methods that are common to all devices. So if I try to compile now, I get an error. I cannot create a, where's the error? I cannot create a MyDevice. It's abstract. So let's take that out and take this out, close it, and recompile, and everything looks good. And you can see the word abstract appear here. And if I run it, everything's fine now. Okay, which makes sense. I should only be able to create my pods and my phones. And MyDevice is too generic. So that's one use of the keyword abstract, is to declare a class as simply a placeholder for methods, for instance variables and methods that are to be used by subclasses. This is not actually going to be, we're actually not going to create a MyDevice. Wouldn't make sense. A second use of the word keyword abstract is a method. I'll say public abstract void connect to Bluetooth, lowercase t, connect to Bluetooth, semicolon, and that's it. There's not going to be any curly brace, there's no code. It's simply stating that there is going to be a method called connect to Bluetooth, and I'll let the subclasses define that code. They might be the same code, they might be slightly different code, or might be very different code, but they will all perform this task however they need to or have to do it, and the subclasses will have that code in them. So this is an abstract method. So if I close this and try to compile, you'll see that I get an error. My phone is not abstract and does not override the abstract method. And probably in my pod class, I get the same method. In other words, I don't have the method here and I need to have it. So let's solve the problem. Let's go to my phone and create the method that does it. Public void connect to Bluetooth 1, 2, 3. And method connect to Bluetooth. Okay, and let me make sure I spell it the same way. We have to make sure it's the exact same spelling. I said connect to Bluetooth. Connect to Bluetooth. That looks good. And connect to Bluetooth. And for simplicity here, I'm just going to say system.out.println connecting to Bluetooth for my phone. Now there might be a special algorithm for how a phone does it versus a MyPod, but I'm just going to print out how it does it, and then I'm going to basically copy this, space there, copy that, and go to my pod and put that in there. I'll say connecting to Bluetooth for my pod. So very same method name, slightly different modification of what it actually does. Again, this might be sets of code for how they actually do it internally. If you think about the game of chess, I might have a chess superclass with a move method, but the move method for a pawn is very different than the move method for a queen. So same method name, but very different code in the method itself. Okay, and if I close it and compile it, everything looks good. All right. And then the power of this is the following. So here I print up my device, but I'm also going to do this. I'm going to say, actually, I'll do this. Device dot connect to Bluetooth. And again, I'm not talking about an actual pod or phone, I'm just saying device connected to Bluetooth. So if it's a pod, it'll run its set of code. If it's a phone, it'll run its set of code. So I don't need to know what device. I just know that we have this method and that both classes actually have code for it. And when I get to that device, I'll run that code. So this is, again, polymorphism. Many different objects, many different shapes, and I'm running the same set of code with it, which is very powerful. I close it, compile it, and actually, this is the Connect Bluetooth itself prints out, so I actually don't need this. I made it so that it actually prints out, because that was in the Bluetooth, the Connect to Bluetooth thing. I'm just simply going to run the method. It will print out. So compile it, close it, and run it. And you can see it went through the array list of two things, but it ran the code for my pod, it ran the code for my phone, but I use the same set of code. I use one set of code to run the method for any device. And as you can imagine, if I had many different my devices, 3, 4, 5, 6 different types, I could run one method to connect them all. I don't have to have separate for loops and say, or if you're this, do that, if you're this, do that. This abstract method that I defined in the subclasses is called for the appropriate device, and I can run through many different objects at once. So those are the two key uses of abstract: to define a class as abstract so that I'm not able to instantiate it because it's simply there as a placeholder, and the word abstract here for a method that says I'm going to define a method, no code. I'm going to let the subclasses define the code so they can specify exactly how to do it. So that's your example of the keyword abstract in an inheritance hierarchy.